iFour Technolab Private Limited, an ISO 9001-2015 certified and leading sustainable IT service provider. Presents tutorial of smart contract using Solidity. The purpose of this course is to give you complete understanding and hands-on experience with smart contracting using Solidity for blockchain technology. In Chapter 12, Introduction to web3.js covers an overview of web3.js and demystifies various web3.js jargons. We are going to discuss the following topics. What is web3.js? Checking account balance. Deploy smart contract web3.js. Make smart contract transaction using web3.js. Call smart contract function using web3.js. web3.js. Interact with the Ethereum blockchain. web3.js allows you to develop clients that interact with the Ethereum blockchain. Library collection. It's a library collection that enables you to perform actions such as sending Ether from one account to another, reading and writing smart contract data, creating smart contracts, and so much more. You may have used jQuery to make AJAX calls to a web server if you have a web development background. That's a good starting point to understand web3.js function. Read and write. You can use web3.js to read and write to the Ethereum blockchain rather than using a jQuery to read and write data from a web server. Checking account balance. Example. Topic is checking balance, so for that first we have to run parity on the back end. First create file invoice.sol and copy paste code from parity.ui that we created in the previous video. Get balance.js file. Port web3 using require web3. Web3 using npm install web3. Set the blockchain network RPC URL into web3 HTTP provider. Now let's create a .env file because we will store our config in the environment. Endpoint. We will define blockchain endpoint with localhost. To install .env package using npm install .env. Request. We will load the .env file using require. Find process.env.blockchain endpoint. It's the get balance function for getting the balance of the account. .eth.get balance function in which we need to pass the account address, so declare an env file. Let's copy from parity UI and paste it in the env file. Env file. That in bytecode, so need to convert that balance in Ether. For that we will call web3.utils. From way method in which we will pass bytecode balance and Ether as a string. Balance using console.log. We'll get a balance method. File using node getBalance.js. You will see the balance that same as parity. Contract web3.js. Example. Deploy smart contract using web3.js. Create file contract.js. Port web3 using require web3. blockchain network RPC URL into web3 HTTP provider. Use .env file using require. Find process.env.blockchain endpoint. Let's create the deploy function. Catch because if any error occurs, so we can catch and print that error. Need to read the invoice.sol file using the fs module, and we will use function read file sync, in which we will set path using path module. We need to import both the module Solidity code. We need SOLC package, so let's import it. The SOLC package, using npm install SOLC at the rate 0.4.24. 0.4.24 is a version of the compiler. Compile source code using the compile method of SOLC. From kitecode, from compiled code using output.contracts of invoice.bytecode. We'll get ABI using output.contracts of invoice.interface. For contract using web3.js. For that we need to create an instance of the contract using web3.eth.contract in which we will pass ABI. Pass ABI. Deploy function of created instance in which we need to pass object contains bytecode. Bytecode. End function, that will create a transaction on the blockchain, in which we need to pass from address, so we use environment address that was we added then gas price and gas. Price and gas. In contract address using console.log, in which we will write down deploy contract.options.address. Address. We will call the deploy function. Contract.js file using node contract.js command. To parity, in which we need to select the local key file, then enter the password, then click on confirm the request. Check in console, you can see contract address is printed. You can see in TXQ viewer one transaction is executed. Contract transaction using web3.js. Example. All transaction using web3.js. Invoice function using web3.js. For that we will write deploy contract.methods.add invoice in which we need to pass to address, so let's add a second address to env. address process.env.account underscore address underscore to amount and subject. Or the send method, cause that will create transactions or block in the blockchain. Address. We will pass from address. We'll write action hash using console.log, in which we will write data.transaction hash. Node contract.js command that will send a request to parity. Key file, and enter the password, then click on confirm the request. That will deploy the contract. That you passed while calling add invoice. You have to choose the local key file, and enter the password, then click on confirm the request. Deployed contract address and transaction hash in the console. Smart contract function using web3 JS. Example. Now call getInvoice function, that will not create block or transaction in the blockchain. Now deploy contract.methods.getInvoice, in which we will pass the index of the invoice. So in this case, we will pass 0 as index, then we will call a method, in which we will pass from address. That result in the invoice array variable. Index that we will get as 0 indexes of invoice. We will get as 1 index of invoice. Will get as 2 indexes of invoice. We will get as 3 indexes of invoice. We will get as 4 indexes of invoice. This we will get as 5 indexes of invoice. We will get as 6 indexes of invoice. Confirm all index with our contract function. file using node contract.js file that will send a request to parity in which we need to choose a local key and then enter the password. Click on confirm request. That will deploy the contract. Same again, select the file and enter the password and click on confirm request. That will add invoice that to console. You can see that first that print contract address, then print transaction hash, then we will see all data printed that we inserted. That's it in this video. Thank you for watching and stay tuned for our next video.